John made deposit of 1,000 into a fund at the beginning of each year for 20 years. At the end of 20 years, he began semi-annual withdrawals of 3,000 at the beginning of each 6 months. Smaller final withdrawal to exhaust the fund. So that's a drop payment. The fund earned annual effective 8.16%. Calculate the amount of the final withdrawal. So the deposits accumulate for 20 years, and then at time 20, you start making withdrawals. So let's collect everything at time 20 in this problem. So first, let's find the accumulated value of the deposits, time 20, because that's the fund from which the withdrawals will be made. And that's annuity due because they start happening at the beginning of each year. So annuity due formula, each deposit is 1,000. Annual effective rate is 8.16%. So 1 plus 0.0816 power 20. There are 20 deposits. And divide by 0.0816 minus 1. And then we know that up to this part, that's the accumulated value of annuity immediate. So this is annuity due. So you multiply by another factor of 1 plus I. So 1 plus 0.0816. So the accumulated value at time 20 of the fund is 50,382. And the withdrawals are also annuity due if you start counting 20 years as the reference time now, because the first withdrawal is made at time 20. And now, although we know that the final withdrawal is smaller, but to know how many there are, we first pretend as if all the withdrawals are the same. And so let n be the number of withdrawals. And the withdrawals are semi-annual, so we will need the semi-annual effective rate according to the formula. 1 plus I is equal to 1 plus I2 by 2 whole square, and we know that I2 by 2 is the semi-annual effective rate J. So I is 0.0816, and so we get J equals 0.04 from here. So now the accumulated value of deposits at year 20 should be the present value of all the withdrawals at year 20, because the withdrawals, including the drop payment, exhaust the fund. So the values should be the same. So accumulated value we already found was 50,382. And the present value of withdrawals at year 20, if we count year 20 as a starting time now, and by the annuity due formula, each withdrawal is 3,000, 1 times 1 minus 1 plus I. And in this case, it's the J that's going to be used because withdrawals are semi-annual. So the semi-annual effective rate will be used. 1 minus 1 plus J to the negative n over J, and then times the 1 plus J because this is annuity due. And we multiply by 1 plus the interest rate in the end for everything. So n comes out to be 26.47, but n is the number of withdrawals, has to be an integer. So this shows that there are 26 regular withdrawals, and then the 27th withdrawal will be a drop payment. Now, recall that this is an annuity due. So in an annuity due, the first payment or first withdrawal happens at time 0, second at time 1, third at time 2, and so on. So it means every withdrawal or every payment happens at one time less than the payment that we are talking about. So third happens at time 2, second happens at time 1. So the 27th payment will happen at time 26. And now we're counting these times in half years. So the 27th payment will happen at the 26th half year. And so that needs to be brought back 26 half years. Remember, time 20 is now the reference point. And so the accumulated value of the fund at time 20 will be equal to the value of the 26 regular withdrawals at time 20 plus the value of the drop payment at time 20. The regular withdrawals are the annuity due. So that's the usual annuity due formula up to this point for the regular withdrawals. And then the drop payment needs to be brought back 26 half years. So times, so if Y is the drop payment, then its value at the reference time of 20 will be Y times 1.04 to the negative 26. And from this equation, Y comes out to be 1430. So you'll first calculate all this out, subtract it from 50,382, and then divide by 1.04 to the negative 26. That gives Y equals 1430. That is choice C.